Hello everyone, welcome back to my channel. Today let's go over a medium level question that I just solved on my own. So I'm very happy about this and I'm glad that I was able to come up with my own solution to this question without any help. So let's go over it and let me show you how I did it. So this is question 3342, find minimum time to reach last room 2. So basically, you're given this grid. It's called a dungeon here with n by m rooms arranged as a grid. And again, you're trying to go from the top left to the bottom right corner as usual. And you're trying to find the minimum time to do that. So you also have this rule where every even move, right? We're starting at 0 because you can't move at the beginning. Then you're going to add 1 to the time. Odds add 2. Alternating between the two. So we just want to return the minimum time to reach the bottom right corner, starting from the top left corner. So let's first create a directions, because we're going to need to move in all 4 directions. It says adjacently, horizontally, or vertically, upright, or right, up, left, right, down, right? So in all 4 directions. Cool. So next, we're going to declare a set called scene. So we're basically just going to run a Dijkstra's, and we're going to have the time and then the x and the y, because we want to sort by the time, right? This is a greedy algorithm. And let's heapify our queue. And then let's just keep running the BFS until our queue is not empty. Let's also get the dimensions of the grid, because we're going to probably need them later. Okay, so while the queue is not empty, we're going to pop off the time and the x and the y coordinate using heap pop, which is going to sort it by this, and then this, and then this. So now let's check if x and y is in scene. If it is, then we continue to avoid an infinite loop. And then we're just going to add x and y every time, so we don't visit the same cell more than once. Cool. And then let's go ahead and explore all 4 directions. We can go up, down, left, or right, right? So the new coordinate is going to be the x change plus the y change. And then if it's out of bounds, then we're just going to continue, right? Otherwise, if it's in bounds, so continue. So if it's inbounds, then basically we can go ahead and apply this rule. So let's call the current time. Let's set that there. And again, you can only move to an adjacent room if, and you can see this by the examples, if the current value of that room is, so the current time is at least the value of that room, right? So you can't move, if the time is 2, you can't move to a cell with a value of 4. So basically what we're going to do is bring up the difference of the current time and that cell. So the cell, let's just call this, if the cell move time new x, new y, because we're inbounds right now, is bigger than the current time, then we're going to add the difference, which is going to be calculated as the bigger minus the smaller. Cool. And let's call this current time. And then after that, again, we also have to keep track of a count, right? So let's call this the count, because we're going to increment that by 1 each turn, starting with evens plus 1 to the time, odds plus 2 to the time. So if count is even, then current time, you have to plus an additional 1, otherwise plus an additional 2, because at the very least, you have to take 1 second to move or 2 seconds to move. And that's not including the difference, because to visit each cell, you have to be at least what the value of that cell is. And we're trying to minimize the time from the top left to the bottom right. So now we can heap push onto our queue the current time, because again, that is the optimal, that's the thing we're trying to optimize by. And then the new coordinates, and then also our count plus 1. So 0 to 1 becomes odd, 1 to 2 becomes even again. So this rule will apply. Cool. And at any point, if we're at the bottom left corner, Then let's go ahead and print the time, and that will give us the most optimal answer because we're doing this greedily, and you can see that it matches the output. So now let's just go ahead and record each time, each best time that we find, in case we find an even smaller time to reach bottom right from top left. And then at the end, we can just return our answer after we finish this BFS, right? So let's run this, submit it. Okay. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any assistance and solve it completely on my own. So that's it for question 3342. This is a medium level graph question.